Computer architecture. Have you ever wondered how your computer opens apps so fast or why sometimes it slows down? These answers lies in something called memory hierarchy. In this video, we are going to explore how a computer stores and accesses data, starting from the fastest memory inside the CPU all the way to long-term storage. Think of it like a race where different types of memory compete in speed, size, and efficiency. Let's begin our journey inside the computer. Now we are at the fastest memory in existence, CPU register. Registers are tiny storage locations located inside the CPU itself. They store the data that the CPU is currently working on. Their size is very small, around 8 to 64 bytes, but their speed is incredibly fast, less than 1 nanosecond. To give you an idea, if memory were a race, register would finish before other even start. Each CPU core has around 16 to 32 registers and they are used for immediate calculation like addition, subtraction and data movement. So whenever your computer performs any operation, registers are the first place where data goes. Now, next we move to cache memory, the CPU smart notebook. Cache stores data that CPU is likely to use next. This reduces the time needed to fetch data from slower memory. Cache is divided into three levels: L1 cache, smallest and fastest; L2 cache, medium; L3 cache is larger. You can think of cache like is your study table. L1 is like your notes in your hand, L2 is like books on your desk, and L3 is like book on yourself. When you open an app again and it's load faster, that's because of cache memory. It predicts and stores useful data before you even ask for it. Now we move to RAM, random access memory, also known as your computer's workspace. RAM stores program and data that are currently in use. Typically size ranges from 8 GB to 64 GB and its speed is around 100 nanosecond. But that's one important thing. RAM is volatile. It means all data is lost when power is turned off. For example, when you open a browser, it loads into RAM. When you open multiple apps, RAM uses increases. If your RAM is low, your system becomes slow because it has to rely on slower storage. So RAM acts like a working desk where all active tasks are performed. Now we reach to storage, the permanent memory. This includes SSD means solid state drive and HDD means hard disk drive. Storage is much larger from hundreds of GBs to TBs but much slower compared to RAM. SSD. This is faster, modern and no moving parts. HDD is slower and uses spinning disk. Unlike RAM, storage is non-volatile, meaning data stays even when power is off. Everything you save, files, videos, software is stored here. So storage is like a library while RAM is your study table. Speed comparison. Now let's compare all memory types in terms of speed. Register is fastest, then cache is very fast, then RAM is moderate and storage is slowest. As we go down the hierarchy, speed decreases, size increases, and cost per unit decreases. This balance is very important for system performance. Next, why memory hierarchy? Now the big question, why do we even need memory hierarchy? Why not just use one type of memory? Because no single memory can be fast, large and cheap all the same time, all at the same time. It means uh, no any single memory is large, fast and cheap at the same time. So we use a hierarchical system to balance speed, cost and capacity. Fast memory is expensive and small, while slow memory is cheap and large. This layered approach ensures your computer work efficiency. Now let's quickly recap. Register is fastest, smallest and inside CPU. Cache stores frequently used data. RAM active workspace. Storage permanent memory. And the golden rule is closer to CPU, faster but smaller, and further from CPU, slower but larger. This is foundation of how computers manage data efficiency. I hope this XR journey helped you understand memory hierarchy in a simple and visual way. If you found this helpful, don't forget to like, share and subscribe. Thank you for watching.